So let's move on and let's go on to the second perspective, which is the numerical perspective, computer science perspective, or a better way to say it is also used a lot in all the engineering too. So this is like a numerical perspective of vectors. So vectors are essentially an ordered list of numbers. For example, 4, 2, 4, 0, 1, 2, 4, minus 1, 2 minus 2.5 and so on. So these are ordered list of numbers, and they are also termed as vectors. So this is the numerical way of representing vectors that we have. So let's take this example and let's see what this could mean, right, in data science and machine learning. So if I have house price prediction problem, which is a common problem in machine learning that you come across, and if you have certain features, for example, if I'm writing something like this, right, this could mean that one of the houses has 4 bedrooms and then it has 2 bathrooms, and we know that the prices of the house could depend on possibly number of bedrooms and the bathrooms that they might have. So here we are using this 2 different unique features of house, which is bedroom and bathroom, right? These are called features, and depending upon the quantity of those features present in a given home, we can represent a given home by the number of bedrooms and number of bathrooms that we have. Okay. So that's an example of what this simple ordered list can represent for you. In this setting, it is representing the number of bedrooms and bathroom, but in different problems, that representation might lead to different, aspect of the problem that you are considering. Now, the second thing I want to mention and quickly, allude to, that they are ordered list, and this is a very important concept when we are thinking about numerical aspect of it. Okay, and what I mean by that is if I change this and switch the order, and let's say if I represent something like this and create a vector which is called 2, 4, which is essentially taking this 2 and placing it up, and 4 and placing in 2, then, and if I'm in the same representation problem, which is house price prediction, this means 2 bedrooms and 4 bathrooms. Okay, so just by switching the order, the quantity this vector is representing is completely different from this. So this is a different house from this house, because this house has 2 bedrooms and 4 bathrooms, whereas this house has only 4 bedrooms and 2 bathrooms, right? So the ordering is very, very important, and you cannot change the ordering depending upon the problem. You have to have the numerical values that you are storing at a different location same. So this ordered list of numbers are essentially the vectors, and that's the numerical interpretation of vectors, and that's the numerical way to understand different vectors. So you can take a vector and you can represent them as an ordered list of number, and that is essentially simplest way of understanding, numerical way of understanding what vectors are. Okay. The mathematical perspective is even more simpler and probably more abstract. So mathematicians think vectors to be anything which you can add, and that addition has to make sense, or a quantity that you can multiply by a given number. As long as these 2 operations are there in your domain, and as long as you can add 2 different things and you can multiply them by a number, you are essentially operating of what is known as vectors. But fortunately for us, we will not, we will be using mostly the numerical aspect in data science. But as I said, even when we are doing numerical things, it's very, very important to have a strong geometric intuition about it. And so understanding the geometric perspective is also very, very important. So with that, let's move on and let's discuss other things. Okay, so first thing, most of the times when we are doing linear algebra or when we are doing matrices operation or vector operations, we are essentially representing the vectors and the matrices in the coordinate systems. Okay, and coordinate of vector is essentially a pair of numbers which basically gives instruction how to get from the tail of the vector at the origin to its tip, and this is something that I have described. So let me deal with it a little bit more with one simpler example that I have here. The first thing, that you need to do in order for understand this concept is like you need to have an axis, x-axis and y-axis for a 2D example. And then let's say you have a vector which has been represented by these two numbers, ordered numbers or two tuples, -2 and -4, right? What this essentially means? How do I start from the origin and arrive, which is the basically the location of the origin of this vector to the tip? What movements do I need to carry out? And that is essentially the vector representation, right? So what we need to do is we need to move 2 units in the x direction, and then we also need to move 2 units in the y direction. So if I move 2 units, -4 units in the y direction. So if I move that -4 unit in the y direction, then I'm essentially arriving at this location, which is the tip. So this number right here, this essentially should be -4, right? And once we are doing these two movements, which is moving -2 in the x and then -4 in the y axis, we are arriving at the tip, and these movements are essentially recorded in an ordered list, and that also represents the geometrical object. So this is the conversion from the numerical to the geometrical representation that is important for you to have some concept of. So let us discuss how does a vector is represented in a coordinate system. Now, in order for us to distinguish between a point and vector, we use slightly different notations, right? One of the things that we do is we use square brackets to denote vectors, whereas we use round brackets to denote points in a space. Let me explain this with an example problem. Let's say we have an coordinate system which is x and y, and if I want to represent a point -2, -4 on this coordinate system, then I will pick this point, and this point will be basically written as -2, -4. So if I'm representing a point, then I will be writing -2 and -4. Whereas if I'm representing a vector which is is having a tail at origin and tip at -2, -4, this vector will be essentially represented by the vector -2, -4 in the square bracket. So the main difference is we are using a square bracket to represent a vector, whereas we are using essentially curly braces to represent round braces to represent a point. Now, discussing this further, we have to remember that each pair of number gives us exactly one vector. So if I pick points here, for example, if I pick this point, and we use this notation, which is, let's say, 2 -2, this point is 2 -2, right? This will be essentially give me just one single vector, okay? There will be no other vector that could be associated with this 2 and -2. Similarly, right, only one pair of number is associated with vector. So if I take this, right, this pair of numbers, they will be associated with just this single vector. And this is an important concept to know when we are talking about, and distinguishing vectors from point and what vectors represent in a Cartesian coordinate. Similarly, we can represent, vectors in three-dimensional. For example, since in 3 dimension we will need 3 tuples or 3 numbers to represent a given vector, we will be using this notation of square bracket. Inside that there will be first tuple, second tuple and third tuple, which each are representing x, y and z coordinates of the location of the tip of the vector when the tail of the vector is at origin. So that is what the vector actually represents in the coordinate system.